Okay, we're continuing our exploration of how to write the equation of a line from lots of different types of information, a graph, a point and a slope, 2 points, a data table. We've actually done some of these things already. With previous work on this. Today we're working on this right here. Okay. So in a previous video, I'd asked you to interact with this question or a previous assignment. If you haven't done that assignment, or if you're not part of my class, you could pause and take a look at this and maybe explore it a little bit. What I was hoping people would come up with is some kind of way of writing, hey, you know, their distance is always going to be some number times the amount of time they've been going, plus or minus some other number, which represents where they started. And we've done some of these things in my class anyway, where we realized that the speed they were going was always the number in front of t. So they're doing 2 feet per second, so their speed right there. And then we needed to come up with some kind of way of getting where did they start at in order for this to work. Okay? Well, here's an option. We could always come over here to a graph, and I started the graph here, and I put the point 512 on there right here because that represents at 5 seconds in, they're at 12 feet. Well, now I've got this line that could represent their travel across. And the problem is it's not tilted right. It's supposed to be going up 2 for every 1 over. So I'm going to take this thing and turn it around a little bit. Okay, so it's more tilted. And let's see if we can get it right through there. And now I notice that it's going up 2 for every 1 over. So if I just kind of trace this back, down 2, left 1, down 2, left 1. In fact, I need to make it a little longer here. Down 2, left 1. I want to make sure it's correct there. Oops. And down 2, left 1. So, okay, now I can tell that it looks like it's crossing. Oops. Right here at 2. So I could say, look, y equals 2x. So the 2 in front of the x represents the speed, and then plus 2, because that's where it crosses the y-axis. So apparently they're going 2 feet per second, and they started at 2 feet ahead of the starting line. Well, that worked okay, but it was kind of a hassle. You could also have maybe done this using Desmos. You could say, look, here's the point 512 representing they're at 5 seconds in, they're at 12 feet from the starting line. And then you could say, look, I know the equation starts with y equals 2x because that's got to be their speed. And then, hey, look at this. We're 2 units below the point, so if I just put a plus 2 there, that worked. Okay. And if somebody had said, all right, there's a new tricycle racer here. Let's turn these off. We got a new racer that was, say, at 4 seconds in, they were 7 feet from the starting line, and maybe they were traveling at 5 feet per second. So we could say y equals 5x, and that one's going to be pretty ugly. It looks like I'm going to have to drop this equation down. Let's try down 10. See if that works. Oops, not that way. Yeah, got to go a little further here. 12. Looks like we're still 1 above, so yeah, minus 13. Well, that works, but that's going to be a real pain, especially if somebody says, hey, guess what? The person's actually going at 4.5, and then at 19 seconds they were 82 feet from the starting line. Good grief, I don't want to mess with a graph on that unless I have to. So here's what I'm going to do. I'm going to take you back to something that you've done before and remind you about that skill, and then use that skill later on. So if I step over here to this kind of thing and I said, look, I want you to write the equation that for a line that goes through all these points. Well, the skill we had learned before was this. You said, I know that as long as these numbers are going up by 1, which they are, then however much these numbers go up by is the number in front of x. So this is going up by 10 every time, so y equals 10x. And then we had to figure out, well, what goes out the back door here? And what we figured out was, especially if they give you the point 0 something, then that y-intercept was right there, and you're good to go. There's your equation. Okay? Well, then we messed around with things like this. What if, and I'm sorry this is in the vertical table instead of horizontal table, what if it looks like this? Well, they're still going up by 1, and I notice these are going up by 5, so here's the equation to start with. y equals 5x. I just don't know what goes right here. And what we figured out we could do is say, look, I know the equation, if I put a 1 in here, I'm supposed to get a 1 out. Or if I put a 2 in, I'm supposed to get a 6 out. So if I just choose one of these x's, I'll just choose an x equals 2. If I put 2 in for x here, and then ask you, what does it take in this box in order to actually get a 6? Because remember, if I put a 2 in, I'm supposed to get a 6 out. Well, this right here is 10. So what are you going to add on to 10 to get to 6? Well, the only way you could do that is if you add on a negative 4. Okay? So now you know what the equation is. It's going to be y equals 5x plus negative 4, or just y equals 5x minus 4. Well, we're going to use that skill right here. I know that the equation has to start with y equals 2x plus something. I just don't know what that something is. Okay, the 2x came from their speed. Well, what I can do is say, look, if I put in a 5 for x, because that's the number of seconds, and I add whatever this is, I'm supposed to get to 12, because they're supposed to be at 12 feet. So, since this is 10, what are you going to add on to 10 in order to get to 12? Well, 2. Okay. So now you can tell that the equation was y equals 2x plus 2. And we did that without a graph. So I'm going to switch over here to another problem here. Same tricycle racer. It's traveling at 8 feet per second. And after 17 seconds, they're at 72 feet. Well, I don't want to mess around with trying to graph the point 1772. And then put a line on there that's got a slope of 8 and try to figure out where it crosses the y-axis. Well, I don't have to. I can say, look, my equation has to start this way, because there's their speed right there. Okay? I just need to find out what goes here to make it fit. Well, what I know is that if x is 17 seconds, then y is supposed to be 72. So let's write those in here. 72 equals 8 times 17 plus something. Well, we need to figure out what 8 times 17 is. Let me get that. That's 136. So now I'm going to ask you the question. What do you have to add on to 136 to get to 72? Well, it's going to be a negative number, and you can find it by just taking 72 minus 136. Okay? And that is negative 64. Right there. So, here we are. Y equals 8x minus 64. So apparently they were starting 64 feet behind the starting line, and they're traveling at 8 feet per second. So let's look at one more. Okay. So here's another tricycle racer. They're traveling at 5 feet every 3 seconds. Okay, so just that right there tells me the equation has to start this way. Okay, we've learned that in previous work. So 5 feet every 3 seconds. I just don't know what the number is out here. So what I'm going to do is, again, say, look, if it's 12 seconds, that's x, okay, and at 27 feet, right there. So I'll put those numbers in. 27 equals 5/3 times 12 plus something out here. Okay? Well, you're going to have to figure out what 5/3 times 12 is, and there's lots of different ways to do that. I like to do it this way. Look, I know 1/3 of 12 is 4, so 5 of them is 20. Okay? So, what are you going to have to add on to 20 in order to get to 27? Well, 7. So, since that goes there, then it also goes there. And here's your equation. Y equals 5/3 x plus 7. So, we're going to do a little bit of work with this, and in the next video, I'm going to show you just more generic kind of problems that use this same skill.